Hi, this is Christy for Hammerhead Ocean Products. Today, I'm going to talk about pressure relief valves. This is the first of a three-part series to introduce better options for your subsea project. When you need to protect crew from dangerous pressure buildup in a subsea housing, the PRV is an essential piece of equipment, but you shouldn't have to lay awake at night worried that it might leak and destroy your mission. Hammerhead has reviewed several PRV designs on the market and evaluated what possible failure modes exist. This exercise resulted in two new designs that take reliability to the next level. Part 1 will discuss the thought process and the resulting standard PRV design. So here we go. A PRV really only has two requirements. It must let excessive pressure out and never let water in. Typically, designs have a spring-loaded poppet that releases gas at a specified pressure level. The poppet seal is also the key to preventing water ingress. The seal must have a proper surface finish and must be positioned and loaded correctly. As a good engineer, part tolerances and surface finishes are well defined. Then quality control is put in place. That's done. What's next? Well, the only things left are proper and repeatable poppet movement and keeping debris away from the seal. As Hammerhead looked to eliminate failure modes, these two areas were our top focus: how to ensure precise motion and stop debris generation. We discovered that virtually all the designs on the market use threads to preload the spring. They also rely on the nut to roughly guide the poppet location. This can lead to problems. So let's take a look at the new Hammerhead Standard PRV design solution and see how it addresses these concerns and takes reliability to the next level. Here is our standard PRV. It looks familiar on the outside. Dual seals that interface with an SAE number 4 port installation hex and a smooth barrel for a vacuum tool. But the big difference is on the inside. It has no internal threads. First, let's step through the failure modes that internal threads can cause. No matter how well you clean threads, there is always a risk that a burr or chip will dislodge when the nut is installed. Also, the rotation against the coil spring tries to rotate the spring and causes scraping, generating small metal flakes. You have to lock the thread to hold its position. This can be a thread locker, Loctite, or a plastic pellet. Since the thread is used to adjust the proper crack pressure, it may be moved around a lot, generating debris. Typically, this small nut is relied on to guide the poppet, but it doesn't have the proper LD to give precise poppet motion. Introducing variation. Oh yes, all the adjustment can leave the nut not adequately locked, allowing calibration to change to occur. Or worse yet, fall off. So let's take a look at the inside of the Hammerhead Standard PRV design. You see the poppet and spring, and notice the poppet stem is smooth, no threads, just a retaining groove at the end. The C-shaped sleeve spacer is used to compress the spring to a precise height. The spacer is a hard, slick plastic part that glides with low friction. It also guides the poppet with the proper LD. The length can be altered to achieve different pressure settings. Here is how it looks assembled. The assembly is held together by snapping a small O-ring into the groove. As you can see, this design addresses all the failure modes discussed earlier. And that concludes part 1 of the PRV series. Please join us for part 2, where we discuss our clean sheet, patent-pending PRV design. As always, please reach out with any questions or comments to sales@hammerheadoceanproducts.com.